Hello everyone, welcome to the lesson. In this lesson we're going to look at a question on linear programming, a question that was there in 1998, paper 2. So let us go straight to that question and see how we're supposed to do it. A dropper is required to supply two types of shirts, A and type B. The total number of shirts must not be more than 400. He has to supply more type A than of type B. However, the number of types A shirts must not be, there's something I've inserted there that was missing, that the number of types A shirts must not be more than 300 and the number of type B shirts not less than 80. Let X be the number of type A shirts and Y be the number of types B shirts. Part A of the question, write it down in terms of X and Y or the linear inequalities representing the information above. B, on the grid provided, draw the inequalities and shade the unwanted regions. These information that are given there. The type A cost 600 per shirt, then type B 400 per shirt. Part 1 of the question again, that is a B part 1. Use the graph to determine the number of shirts of each type that should be made to maximize the profit. Then 2, calculate the maximum possible profit. So that is the question. Let us jump straight to the solution and see how we are supposed to solve that. Now we're going to begin by writing down the inequalities, and already we have been given that X will represent the number of shirts for type A and Y the number of shirts of type B. So that is the first thing. Already I've written it there. Now the first statement that is going to give us the first inequality is here. The total number of shirts must not be more than 400. Must not be more than 400. That includes the type A shirts and type B shirts. So what does it mean? If they must not be more than 400, then the inequality should be, when I get the sum of type A shirts and type B, they should be less than or equal to 400. That is what we mean, that they should not be more than 400. He has to supply more type A than type B. That on we have another inequality that we're going to write here. He has to supply more type A than of type B. So meaning the number of shirts for type A, which is X, must be greater than the number of shirts for type B. The number of shirts for type A, which is X, must be more than the number of shirts for type B. So that is the second inequality. Now the other inequality, however, the number of types A shirts must not be more than 300. The number of types A shirts must not be more than 300. That means that the number of shirts for type A, which is X, must be less than or equal to 300. That is the meaning of must not be more than 300. And then the number of type B shirts not be less than 80. Not be less than 80. The number of type B shirts not be less than 80. So type B is Y. That one should not be, may read again, should not be less than 80. Should not be less than 80. Therefore it should be greater than, or equal to, greater than or equal to 80. That is the meaning, that the shirts for type B should not be less than 80. Therefore they should be more than or greater, that is greater than or equal to 80. Now let me see whether we have another. I think we have exhausted all the inequalities. Those are the possible inequalities. Of course we have the other inequalities that basically don't need to write it, but it is good to always write it, that also the number of shirts for type A should be greater or equal to 0. Then again for Y should also be greater or equal to 0. They should be non-negative. This constraint for X and Y which represent the number of shards for type A and B, should be non-negative. So these two are also important to be there. So these are the inequalities that you're supposed to have in that question. Now after doing that, on the grid provided, draw the inequalities and shade the unwanted region. Now we're supposed now to draw these inequalities, and to draw these inequalities we start with the first one here, x, which is x. So the first one is x plus y is less than or equal to 400. So the line that you're going to draw is x plus y is equals to 400. That is the line that you're going to draw. And to draw this line, we need at least 2 points. 2 points are okay. That one can be used for confirmation. So when x is 0, y is 400. Then when y is 0, x is 400. Those 2 points are enough. You can add that one for confirmation. So that is the line that you're going to draw. Then for the other inequality, that is x is greater than y, this one, the line that you're going to draw is x is equals to y. That is the line you're going to draw. Then we have the other line here, which is x is less than or equal to 300. The line you're going to draw here is x is equals to 300. Then for y is greater than or equal to 80, the line you're going to draw here is y is equals to 80. Now the other lines are, this one represents this one is the y-axis and this one is the x-axis. Now it is also important to note that this line will be broken. It will be broken. You can see it is the symbol here is less than, is greater than. Then this line here should be continuous. This one should be a continuous line that you're going to draw. You can see the symbol here, less than or equal to. This one again should be continuous. This one is a continuous line. And do you have another one here that you can also, this one should be a continuous line. Now those are the lines that you are going to draw. So let us go straight to the graph and plot them. So the graph is here. I've already drawn for the interest of time, the x-axis and the y-axis. So the y-axis, the number of shards of type B, then the x-axis represents the number of shards of type A. The scale I've used is 1 centimeter represent 50. So I'll start by drawing the first one, that is x plus y is equals to 400. So 0 400. So 0 400 should be here, and then 400 0 400 0 should be here. 400 0 should be here. So that line should come all the way from here. This should come from this point. So that is the line. That line should be continuous. You can see it is passing through those 2 points that are 0. These 2 points, they are these 2 points that are here, 0 400 and 400 0. Just to confirm, these are the points. These are the points where the line is passing. It's good to indicate the equation against that line. So this is x plus y. X plus y is less than or equal to 400. Now the other line is x is greater than y. So that line should be broken. X is equals to y, or y is equals to x. It's the same. Y is equals to x. So that line is here, the line that passes through the middle. That line should pass through between the two axes, between the x and the y axis. So you don't need to have points to do that, but you can just have some few points if you wish to have. Like 1 is 0 0, and you can choose 150, 150. You can choose let me just choose here x, y. So remember, x is equals to y, so when x is 0, y is 0. When it is 150, x is 150, y is 150. So you can use this one to plot, or maybe you should know that the line should pass through the center. So the 2 points, 0, 0 is here, then 150, 150 should be here somewhere there. So let me plot this, let me draw this line. So that is the line, that is the line, and let me write the inequality, that is x is greater than y, x is greater than y. Now it is good to note that this line should be broken, so I'll just leave some section there to indicate that it is not continuous, just rubbing some sections there to show that it is not continuous line, like that. Now the other line is x is equals to 300, x is equals to 300, x is equals to 300 is that line is here. X is equals to 300 is the line that passes through here. X is equals to 300, that is the line. It should be continuous. X is less than or equal to 300, that is the line. And then we have the other line, y is greater than or equal to 80. Y is greater than or equal to 80. Y is equals to 80 is the line that we're going to draw. Y is equals to 80. Y is equals to 80 is here. The line is here. So 50. So 1 centimeter represents 50. So one small square is a 10. So 60, 70, 80. This is a 60, 70, 80. So the line should pass through that point. That is where it should pass. That is 60, 70, 80. So this is the line. Y is greater than or equal to 80. Now after drawing all the lines, now we have drawn all the lines, it is important now to shade, to know the side that you're going to shade. Now remember, when you're shading, we shade the unwanted sides. So we start with the first one. X plus y is less than or equal to 400. So to know the side that you're going to shade, we just need to pick, the line is here, we just need to pick 1 point on either side of that line. So I'll pick a point that is on this side, 0, 0, and then I test. So let me pick a point, just start the page here. So I will have x plus y is less than or equal to 400. So if I pick a point like 0, 0 and I substitute here, x is 0, y is 0, substitute here, you get 0 is less than or equal to 400. So that side where I've picked that line has satisfied. So this side is wanted, so the unwanted side therefore is this side that is here. This is the unwanted side. Since the point that I've picked on the other side of the line has satisfied the inequality. Now the other line that I should let me go to the other line. The other line is x is greater than y, x is greater than y, x is greater than y. So x is greater than y is this line, this is the line. So I want to know whether I'm going to shade this side or this side. So what I'll do, I'll pick a point that falls on this side, like 0, 100 is on the top of that line, or maybe I can pick 100, 100 and 200, 100 and 200. So x is greater than y. So let me pick point that is 100, 200, 100, 200, 100, 200. So when you look at these, x is 100. Is it greater than y, which is 200? Is it greater? Is 100 greater? No, no. So that side that where I've picked the line has not satisfied the inequality, and therefore it is the unwanted. So this side is the unwanted where I've picked that point. So that side, the whole of that side of that line is unwanted, because the point that I've picked on that side, that is 100, 200, has not satisfied that inequality, so that one becomes the unwanted side. Alright, now the other line is x is less than 300. X is less than or equal to 300. So here is a line. So this line, you just look at the right hand of that line is greater than, and we need less than. So the side that is unwanted is to the right of that line. X is equal to 300. Why? Because the inequality requires the less than. Less than is to the left of that line. That is the side that we require. It should be less than. So the greater than side, which is the right hand side, is not required. So that one, we shade it like that. Then the other one is y is greater than or equal to 80. Greater than or equal to 80. The top of that line is greater than, the bottom of that line is less than. So we don't require the less than side. The bottom of that line is not required. It is not required. So we shade that. We require the greater than side, which is the top of that line. So this is the line. Now after doing that, we remain with a region here that is at the center there. That is called the feasible region, or the required region, and that is where we shall get the points that satisfy all these inequalities. Now after doing that, now we have drawn and the inequalities and shaded all the unwanted regions. There's something that is given here. Type A cost 600 per shot, then type B 400 per. Use the graph to determine the number of shots for each type that should be made to maximize the profit. Now from these two, we shall be able to get something that we call the objective function. The cost of type A shots is 600, so all the shots will be for type A will be 600 multiplied by x. Then type B, one shot is 400, so y number of shots for type B will be 400 y. This is what is going to help us to get the profit, and this one is referred to as the objective function. The objective function is what you use when you're maximizing or minimizing the profit. Now use the graph to determine the number of shots for each type that should be made to maximize the profit. Now using the graph, we are going to use inspection method. We are going to use the inspection method. There are various methods. You can use the sliding line or the inspection method. Now in the inspection method, we do consider the feasible region, the required region, and then we test the corner points. So test the corner points. The corner points of the feasible or the required region. So which are these corner points? Which are these corner points that we're talking about? The corner points are here. Just have a look at them. We have because this line is broken, these corner points will not be applicable. The points that lie on that line will not be considered, since this line is broken. You can see x is greater than y, so all the points that lie on that line will not satisfy the inequality. That is why that line is broken. So these corner points, the two of them that lie on that line, x is equals to y, will not be considered. So we remain with only these two. We have this point here, that is 380. So this point that is here, 380, that is what the first point that we're going to test. So 380. 80. That is one. And then we have another one here that you're going to test. This one is 300 100. 300 100. This is the corner point of the feasible region. So 300 100. So 300 100. So we test these, and we are going to test these using the objective function. The objective function is here, 600x plus 400y. 600x plus 400y. That is what is going to give the profit. So we can substitute. The first one is when x is 300, you get 600 300 plus 480. So what do you get for that? So very fast, using the calculator. So just work out that one using a calculator and get the solution. So let me multiply these and see. So 600 multiplied by 300 plus 400 multiplied by 80. So this one gives 212,000. That is what you get. So that is what you get for that. Then the second one you're going to test 300 100. So 600, we substitute. When x, so using this is the objective function, and then we are substituting these values of x and y, plus 400 in this case. So this is the x and this is the y. So this one will give at this point 300 400 will give multiply these. This will give 220,000. 220,000. That will give 220,000. So I think I've already solved the last part. So use the graph to determine the number of shots for each type that should be made to maximize the profit. So that is a process called optimization, and the number of shots that should give maximum profit we already identified. It is these. They are here. So this is what has given us the maximum. After substituting here, that is what has given us this one. Remember, it gave us that. So the one that has given us maximum profit is 300 100. So the solution for that is 300 300. So x is equals to 300, then y is equals to 100. That is the number of shots for type A, 300, number of shots for type B, 100. Then we have calculated using the objective function. After substituting here, we have been able to get the maximum profit. So after substituting here 600, substituting the value of x in the objective function, which should give us the maximum profit, then plus 400, that one has given us 220,000, and that is the maximum profit that you're supposed to get. So that is basically how you are supposed to solve that question, by simply identifying the inequalities, plotting them, and later on optimizing. Thank you so much.